Hello. This is a short video just to go over the answer keys for the Unit 3 worksheets so that it will give you support for the final exam. So this 1.1 worksheet, the first question is asking your relative was in desperate need of cash and asked you to loan them $2,000. To avoid losing the case on Judge Judy in the event they fail to repay you, you write a contract charging your relative 5.6% simple interest per year. So we have to remember that simple interest is paid only on the one-time principal. So part A says calculate the interest your relative would pay if they took 10 years to repay you. So the amount borrowed was $2,000. The rate is 0.056 in decimal form, and 10 is the number of years that they are going to pay interest on. So the total interest is $1,120. What would be the future value of the loan if you demanded to repay them? They repay the loan in 5 years. So the future value is $2,000 is your principal times 1 plus the rate at 0.056 times 5 for the number of years instead of 10. So in the end, they would owe you $2,560, and that includes the interest. Part C says, write an equation to model the future value of the loan to your relative. So in part C here, we're leaving T blank in case they want to change the number of years it will take them to repay the loan. Letter D says, what type of equation, linear or exponential, did you write in C? So it was a linear model because it's growing the same amount every year. That's the definition of simple interest, where the parameters are P is 2,000, the R rate is 5.6%, T represents time in years, and A is your future value. The second worksheet for Unit 3 is all about the effective rate and compound interest. So question 1 says, calculate the effective rate of a loan, nominal rate of 7.35%, compounded hourly, and explain what it means. So here is the formula for effective rate. The effective rate is a way for us to put different compounding options in a comparable apples to apples comparison. So because we are compounding hourly, we have to go to Desmos and say that hourly means there are 24 hours in a day times 365 days in a year. So that means there's 8,760 hours in a year. So that's why we have to have N is the number of compounding periods total. And then our rate is 0.0735, and it comes out to be the same as 7.63% simple interest. Question 2 is asking you that you have $12,000 to invest for 5 years. Decide which investment is better. So there's a number of ways that you can do this, but using the effective rate is the most simple way. So A is a savings account that is 1.98% interest compounded continuously. So this right here that it's kind of hard to read is the letter E for the compounding continuously formula. So if you invested that $12,000, you would have $13,248.80 at the end of 5 years. Option B is compounding monthly for 5 years. So you have 12 monthly compounding periods and 12 times 5 overall compounding periods for 60 at a rate of 2.18%. And that is going to give you $13,380.62. The third option is a simple interest option at 3.2%. And so that future value is calculated here on part C, and that gives you $13,920. So simple interest part C is the better option. Question 3 says, what if you had 50 years to invest the same money as you did in parts A, B, and C in number 2? And that would in turn, because of time, the benefit of time of 50 years, the letter B, compounding monthly at 2.18%, would actually yield the biggest amount of $35,656.01. And then number 4 is just asking you to compare and contrast simple and compound interest. And compound interest is going to be better over time. The Unit 3.3 worksheet. So this worksheet has you buying a Bugatti, which is a very expensive vehicle. That the payment, I'm sorry, the price is $1,075,000. And it says, what would your monthly payments be if your loan was for 60 months? And it says up here that we had $500 to put down on the vehicle. So to figure out how much we're borrowing, we're going to take the price, $1,075,000, and subtract the 500. So we're borrowing $1,074,500. I'm missing a zero here, but my formula is correct. And so we have 0.06 and 12. And 1 minus a negative n. And so it says we're going for 60 months. So we're going to put in a negative 60. And so there's our payment, $20,773. So I'm validating that payment. Part B says you are lucky. You won the lottery 29 months into your 60-month loan and decide to pay off your loan early. So this unearned interest formula is a little bit different than what we did in our class. So our unearned interest formula is taking the interest left times the number of payments left. So there's 30 payments left times 30 plus 1. Over there were a total of 60 payments times 60 plus 1. And the total interest that we would have paid, I'm going to show you that formula on my paper here. So had we made these payments for 60 months, this is how much we would have paid overall for the car. 1, 2, 4, 6, 3, 8, 6. Minus what we borrowed. So we would have paid $171,886 in interest. So our unearned interest formula is the amount of interest times the remaining payments times the remaining payments plus 1, all over the original number of payments times the original number of payments plus 1. So our unearned interest should be $43,675.95. And it's just slightly different because this is a different way that we used to do for unearned interest. So this is really how much you would have saved, 43,675 and 95 cents. Then calculate the payoff amount. So the payoff amount is not this here. It is going to be our payment, which is 20,773 and 10 cents times the 30 remaining payments. Subtracting our unearned interest, 43,675 and 95 cents. So our payoff should be 579,517 and 5 cents. So just a little bit different than what we have here. It's a different way of calculating it. The second part to the worksheet is a credit card, calculating the interest on a credit card. It says we had a balance of $1,302.63. And then you can see that we had these payment transaction dates. So we're going by these days of the month. Also note the way they wrote this in the date, that this is the day of the month and 12 is the month. And so if we rewrite in our table here the correct days of the transactions, December 1st, 5th, 8th, 14th, 23rd, and 26th, these are the balances that we had on those days. We started with 1302.63, and we were at that balance for 4 days until we made a payment of $250. Then we were at that balance for 3 days, and we made a purchase of $69. We were at that balance for 6 days. We made another purchase of $87.50. We were at that balance for 9 days, and we made another purchase for $56. And we were on that at that balance for 3 days, and then we made another purchase at $195 for the airline, and we were at that balance for 6 days. So my balance times my number of days is over here up to the right, and my total was 38,536 and 53 cents. And so when we divide that by the number of days in December, which is 31, our average daily balance is 1,243 and 11 cents. So we take that average daily balance and multiply by my monthly interest rate of 0.025. Our finance charge should be $31.08. It says find the new balance on January 1st. So that would be my ending balance of $1,460 and 13 cents from up here, and adding the finance charge. So my new balance would be $1,491 and 21 cents. Part D says if the credit card company used the unpaid balance method to calculate interest, how much would you owe on 1/1? So on that case, it would be the ending balance of $1,460 and 13 cents times the 2.5%. So we would have paid $36.50 as a finance charge. So about $5.42 more. Part E says if you made no additional payments or purchases, how much would you owe? How much would you owe after 4 months using the unpaid balance method? So we would continue to pay interest on the remaining balance for these months. And it turns out to end up being a compound interest formula. If you use your beginning balance of $14.60 and 13 cents and take that to 12 monthly payments, and we made 4 of them, so 1/3 of those, after 4 months, we would owe this right here, $1,611 and 71 cents. The next worksheet is for 3.4, and this is over the student loans. So let's read through these for a moment. So this student is taking 16 credits, and we have tuition, student service fee, estimated class fee, room, meal plan, books and supplies. So the total for each semester, fall and winter, and the total for the year. So it says calculate the total cost of a degree, assuming the student completes 2 years. So that means it would be the $18,590 for 1 year times 2. So the cost would be $37,180. Then part B says calculate the total cost of a degree, assuming a student lives in the community and completes in 2 years. So I would assume there's no room and no meal plan in that case. So I took the $9,295 from the semester and subtracted the room and the meal plan, and found that a semester it would be $4,345 times 4 semesters, so a total of $17,380. And then if you thought about the fact that you might have to pay rent, let's say it was about $12,000 for the year, and then groceries for the year, it would be about $39,780. Now, also you have to remember that that's for a whole year in an apartment, whereas living on campus does not include the summer months. So just some things to think about when you're calculating those. So your totals for your costs might be a little bit different depending on how you were thinking about them. But if you use the, we decided to use the direct subsidized and unsubsidized fixed rate of 4.529%. And so if you did what they borrowed to live on campus, his monthly payment, his or hers, would be $385.85. And I just wanted you to get practice with that formula. So, and then if we calculated the interest that would be earned before first payment, then it would be what he's borrowing times the interest rate divided by the number of days. So they're paying about $4.61 per day in interest. And if you multiply that by the 2 years and 6 months, that 461 times 2.5 years, oops, times 365 days, that's for 1 year. Whoops. That's for 1 year. So 1683.80 times 2.5 years. So it's about 4,209 in interest. So we calculated ours a little bit different, I think, based on the fact that it was maybe not waiting a whole 6 months to start paying. And then 4 says calculate the monthly payment for a direct unsubsidized loan. So one that was getting interest. So we took the $37,180 and added in the interest, and that's what you were borrowing here at $40,967. So the key is to remember, I'm going to be assessing you over just your understanding of the difference between subsidized and unsubsidized, not having to work through one of these big problems. Worksheet 3.5 is over the stock table. So this is the Nike stock. It says, what was the highest and lowest that the stock sold for during the last 52 weeks? And there is the 52-week range. Is the stock market more or less volatile? So the beta is 1.11, which means it's more volatile than the rest of the market because it's bigger than 1. How many shares are currently outstanding? So we had to use the 144 market cap over here. And that is equal to the number of shares times the current price of 92.28. So when you divide by that, you get 1,566,894,235 shares. And this company does pay a dividend. And the dividend is 88 cents per share. So Part D says if you own 273 shares, you would multiply that by 88 cents and you would earn $240.24 each year in dividends. And then question E says, if you purchase 1,213 shares of Nike stock and the commission for the broker is 3.1%, what is the cost of the purchase? So we have the cost of the stock here, and then we have the cost of the commission at the 3.1%. So the total cost of purchasing that stock would be $115,405.64. If you sell all of your stock from Part E and it sells for $111.15 per share, what would your profit be? So we have to sell the stock, and then we have to figure out the commission rate, and we subtract that commission value. So the sale of the stock nets us $130,645.38. And when we subtract what we paid for this stock up above, our total profit would be $15,239.74. And then the back side is asking you some questions about treasury bonds. So it says, suppose you purchase a 30-year bond for $2,000. How much will you earn when the bond matures? So it was a $2,000 bond, and our rate is at 11.75% on a 30-year. We use this top one here for 15 years. So we purchased a 30-year bond on 11/15/2009. And that should have been multiplied by 30 years because it was a 30-year bond. I don't know why I multiplied by 15. So it should be 2,000. Nice. So the interest should have been 7,050. So the value of the bond should be $9,050. And then it says if you sell the bond for $1,900 3 years before its maturity date, what is your annual rate of return? Well, if that's the case, and we sold it 3 years before, that means we would have earned only 27 years of interest. So we would have earned 6,345 interest. And we that means we would have subtract the $1,900 that we got paid. So we would have profited 4,445. Well, no. So we got $100 less back than what we thought. So actually it's minus $100 less. So 62.45. And so that's 6,245 divided by the $2,000 that we originally paid for it. So we whoops. It would be the interest we earned divided by the 27 years. So oops. So we earned out of the 2,000, we earned 312% interest. So 312.25% interest divided by the 27 years. So we actually earned about 11.56% interest. The last worksheet is not scanned in very well. But if you follow the tax table, see if I can zoom in. I need to rescan that. If you follow the tax table that's on there, there's going to be a tax at 10%, 15%, 25%, and 28%. And so their taxes would be $44,857.35. And then it's asking you to do the other tax table, and the taxes would be $40,463.90. Reach out if you have any questions, since this is not very clearly written. Have a great day.